Welcome to True Projects. In this video, we are going to explain about a project titled A Machine Learning Approach for Early Detection of Fish Disease by Analyzing the Water Quality. This project presents a novel machine learning technique to detect the fish disease at an early stage by examining the quality of water. The primary object is to predict the health condition of fish by employing a gradient boosting algorithm trained on a dataset that includes the water quality information. By analyzing the level of toxins and viruses in the water samples, it becomes possible to identify the potential diseases that may affect the fish. This approach offers a proactive strategy for monitoring and effectively managing the fish health in aquatic environments. The objective of this project is to create a machine learning approach that can detect the fish disease early by examining the water quality. By using a data set of water quality information to make the precise prediction about the health status of fish. By identifying the factors in the water samples that could indicate the potential disease, the project aim is to offer a proactive and effective method for detecting the diseases in aquatic environments. The basic requirements that are needed to build this project: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Water Quality Dataset. This module allows the users to upload the water quality dataset to the application. The dataset contains information about various water quality parameters such as the presence of chemicals, E. coli and other viruses. And the second module is Pre-process and Normalize the dataset. In this module, the uploaded dataset is pre-processed to convert any non-numeric data into numeric format, as machine learning algorithms typically require the numerical format. This may involve encoding categorical variables or handling the missing values. After pre-processing, the data is normalized to ensure that all the feature values are on similar scale. Normalization helps in improving the performance of machine learning algorithms by preventing the certain features from dominating others due to their larger magnitude. And the third module is feature selection. Feature selection is an important step in machine learning to identify the most relevant features that contribute to predicting the fish condition accurately. This module selects the X training features and Y class label from the pre-processed and normalized dataset. The dataset is then split into training and testing part, typically using an 80% for training that model and 20% is reserved for evaluating the model's performance. And the fourth model is Train Gradient Boosting Algorithm. The training set obtained from the previous module is used to train a gradient boosting algorithm. Gradient boosting is an ensemble learning method that combines the multiple weak prediction models to create a strong predictive model. During training, the algorithm iteratively builds a series of decision trees, each focusing on the errors made by the previous trees. The trained model learns to make accurate predictions based on the water quality features and their impact on fish health. The training process aims to achieve the high accuracy in predicting the fish condition. And the final module is Predicting the Fish Condition. In this module, users can upload the test data, which contains the water quality information for which they want to predict the fish condition. The trained gradient boosting model is then applied to the test data to make the prediction. The model uses the learned pattern from the training data to classify the fish condition based on the input water quality features. The prediction output provides insight into the whether the fish is healthy or affected by a disease based on the analyzed water quality. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first file is dataset folder, which consisting of test data and the trained data. And this is the main code file named fish disease. And this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. Here we get a screen like this. This is the graphical user interface. With this we are interacting with the program. First we need to click on upload water quality dataset. Using this button we are going to import the dataset from the corresponding folder. Then select the water quality worksheet and click on open button. Here we can see that the dataset is loaded. And also in this screen we can see dataset contain the both numeric and non-numeric values, and machine learning algorithm accept only the numeric dataset. So by applying the label encoder class we can convert the non-numeric data to numeric values. For this, click on pre-process and normalize dataset button. Here by this we can get that dataset pre-processing is completed. Hence the non-numeric values are converted into the numeric value by using the encoder class. And now click on the feature selection button to extract the X and Y features from dataset and then split into the training and testing part. In this screen we can see dataset total values, and also in this graph we can see X-axis represents the number of records and the Y-axis represents the presence of coliform and E. coli virus, where yellow line is for E. coli and the blue line is for coliform. And now close this graph. Here total number of records found in the dataset is of 1991, and the dataset is split into the training part and testing part. Here we use a training part of 80%, that is 1592, and 20% of a testing part, that is 399. And then click on train gradient boosting algorithm button to train the algorithm. And here we got a confusion matrix. Here X-axis represents the predicted class and the Y-axis represents the true class. And we can close this graph. Here the gradient boosting algorithm gives an accuracy of 97.7 and precision of 97.4, recall of 96.5, F-score of 97.02. And now click on predict fish condition button, and then select the test data for model performance and then click on open button. Here we get a screen where the square bracket we can see the test data values, and after the arrow symbol we can see an statement like a fish will get affected by coliform and E. coli virus for this data, and for this data it say that it is an healthy fish. In this way we can detect the fish disease by using the machine learning approach of train gradient boosting algorithm. Finally, I conclude that machine learning approach presented in this paper demonstrates the potential for early detection of fish disease through the water quality analysis. By training a gradient boosting algorithm on a water quality dataset, the model achieves the high accuracy in predicting the health condition of fish. This approach offers a proactive solution for managing the fish health, enabling the timely interventions and ensuring the well-being of aquatic ecosystems.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.